Game theory. This will not be a chapter on board games or video games. At least not directly. Maybe if you want to apply it, but no, this stuff's much more general. You see, game theory is in kind of the same mindset as the oligopoly chapter. And it is the study of how people strategically interact. Now, in the oligopoly chapter, we mathed the crap out of it. And we looked at 4 very specific games. A collusion game, a Cournot game, a Stackelberg game, a Bertrand game. Those are actually all tiny subsets of game theory. Now, we started with those because they flow fairly naturally from the monopoly stuff. So looking at market power. Now we're going to zoom out and do something that feels completely different. Common ideas, though. We still will have a best response function of some kind. Now, if we're in a little game square, the best response just looks like us underlining the best responses to each action. If we're in a decision tree of some kind, the best response is us just choosing the branch that gives us the best outcome in the end. But the general idea of, based on what you're going to do, what's the best thing that I can do? That still holds. That's the essence of game theory. And specifically, that's the essence of Nash equilibrium. Nash equilibrium is just our label for when everybody's playing their best response at the same time. And if that's the case, then there's no reason for the market to change. If everyone's playing their best response, then if anybody were to move, that would just make us more poor. So we're not going to move. Anyway, so I want you to keep that in mind. Just like with Cournot, I have my best response, you have your best response. How do we solve for equilibrium? We figure out where the best responses overlap. Keep that, because that's still true here, even if the math is very different. And honestly, the math's a lot lighter in this chapter. So let's get to some examples. I have behind me an old picture of some warriors in World War I. I think these guys are British, but whatever. And they are in a trench. Yeah, we dug that hole in the ground, dug it long, and now we all wait there with our guns. And if any bad guys come, we shoot them. Now, this was before we had cool airplanes and stuff that could fly overhead and just blow these people up. And so the trench was actually kind of, it was like a major creator of stalemates, because you'd have 2 teams of soldiers looking at each other and they wouldn't know, and they wouldn't make any progress. They'd all just sit in their trenches and occasionally shoot each other. You might remember a scene. Hang on, let me see if I did. You might remember this scene from the original Wonder Woman movie, where she steps out of a trench, knocks a bullet out of the air, and then kicks everyone's butts. Yeah, she's pretty awesome. But I'm not focusing on her for the trench warfare chapter because she's fake. So yeah, we're just gonna leave these guys because these guys are real. Anyway, so why do I start with this trench warfare idea? Well, picture, you got 2 teams of soldiers. They're dug up in their lines across the way from each other. And they both have 2 choices. They can either stick their head over the trench. Let's be more dramatic. They can either try to cross to the other person's place, or they can stay put. Right? I know it's kind of like, that's like your default 2 options. And for any given game, if we played that as a 1-stage game, their best response is probably to stay put, because they know if they try to climb out, they're going to get shot and killed. And both teams know that. If I stand up, I will die. So my best response is to stay down here. Now, these trenches got cold and miserable. They were out there with not enough warm stuff in these muddy trenches or iced trenches in the winter. They were all freezing and miserable. And sometimes the equilibrium in a situation is not a pleasant place to be. Sometimes the equilibrium, if we could just collude, would be way better for us. Last week we talked about collusion as a way to make more money. Okay. Yeah, we have an equilibrium we have incentives to cheat and to compete with each other. But if we could somehow sustain collusion, we'd both be better off for it. Financially, not morally, right? Same kind of idea is going to be at play here in this trench warfare example. Yeah, we're both doing our best response. But in reality, if we could all just cross and walk past each other and move on with our lives, then, I don't know, war sucks if you're stuck in it, right? No one wants to be stuck there. The Nash equilibrium can really be lame sometimes. Anyway, I don't want to get too bogged down in this. You're going to see lots of examples in our book, right? It's going to be about firms, whether they want to open up a new store. It's going to be people, whether they want to cheat or rat each other out. The prisoner's dilemma is actually the classic explanation for what I'm talking about, these trench guys behind me. The prisoner's dilemma is one where, like, the backstory is basically two people are captured. They're not actually friends. They were just doing a job together. A job, like the illegal kind from the movies. You know what I mean? They're doing a job. They got arrested. And the interrogator says, hey, if you narc on your friend, we can cut you a deal. And if you don't narc on your friend, we won't. Worse than that, if you don't narc and he does, then you're going to be in here for a very long time. And if you've ever watched like a cop show, you've probably heard that kind of discussion anyway. It's very cliche. But the reason they do that, that's actually a fairly real thing that we do in our justice system, is it creates incentive for both players to want to rat each other out. Right? If I don't rat and you don't rat, we're going to both be in jail for the crimes we committed. But if I narc on you and you don't narc on me, I get to walk away free while you stay in jail and rot. But if I don't rat and you do, I stay in jail and rot. We're not even friends. So obviously, as criminals, we'd both be better off if we both just zipped it. But there's incentive for us individually to rip off our buddies. And that leads to a lot of confession, which helps smooth over the justice system. To what extent that's used, to what extent it's used fairly and ethically, that's a discussion for another day. But it's something we do. It creates incentives for people to confess their sins or their crimes. You know what I mean? Okay, so that's a prisoner's dilemma. It's a form of a one-stage game. It's got a Nash equilibrium, and that equilibrium is less good than if we both colluded. Not all one-stage games will be like that. Then we're going to talk about repeated games, which is going to bring me back to these trenchies behind me. What if, instead of it just being a one day, hey, we're in a trench, it sucks, what do we do? What if we're here every freaking day and we don't know how long it's going to last? It feels like forever, but for however long it is, we don't know how long. Well, we're going to call it an infinitely repeated game. I know that time is not infinite, but if you don't know when it ends, all you know is it's going to keep going for the foreseeable future. We're going to model that as if it doesn't have an end, because no one knows what the end is, right? So infinitely repeated game just means that your players don't know when it ends and that they're playing for as long as they can think of. So why do I bring these trenchy people up? It's pretty interesting. You got opposing teams who just want to shoot each other. And yet, a lot of cooperation ends up happening. There are stories of these guys where certain hours of the day would be no fire time. There are stories of these guys respecting each other's lunch hour. There are stories of these guys going on patrol at night, walking in the no man's land between trenches where everyone's supposed to kill each other. And when they encounter another patrol, they'll just kind of like wave and walk away. There are stories of guys who accidentally fire artillery during the lunch hour where no one's shooting, and the soldiers who shot it scream across the trench, "We are so sorry. That was an accident. This artillery is crap. I hope no one got hurt." There are stories of officers driving up to a battlefield during these no fire zones, and both teams just firing shots needlessly in the air to make it sound like it's still a battle. Like, and then of course the famous one. So some of those you might not have heard, but maybe this one you have, which is on Christmas, they all climbed out and sang hymns, sang like Silent Night together and stuff, and like had a good time. How does that happen? Well, we're going to talk about that a lot in the technical videos. But the gist of it is this. We're stuck here in this game, this happening between these two players, these two teams. And the Nash equilibrium sucks in this game. And we're going to have to play this Nash equilibrium every freaking day for the rest of eternity. So at some point, you start adding on suck after suck after suck, and this sucks and this sucks and this sucks. And eventually, that like really creates even more incentive to cooperate, to collude. In a one-time game, nah, it's not going to happen. But if we're all stuck here together for a very long time, we might find ways to make it a little less miserable on each other. Now, how does this relate to business? Well, same idea. Competing means lower profits. If we're competing one time in a short-term market, there's not going to be any reason to collude. But if you're in a market that interacts repeatedly, it's not just 1 year's profit you're giving up by fighting each other. It's every year's profit. And that might create a space for cooperation, which, don't forget, with businesses is usually illegal. But hey, it's a thing anyway. Yeah, if we don't know how long we're going to be here, though, and we know that each day is better if I get a good lunch and I'm not going to get blown up, like if I just get a couple hours off, that's better for both of us. And that might create incentive for us to cooperate a bit. If businesses decide, you know what, if we just cooperate a little bit, we get X number of more profit, that's an inviting thing. And so we're going to deal a lot with that and measuring that. The last kind of game we're going to talk about in this class is a sequential game, where instead of like us meeting at the same time, either once or repeatedly, what if we take turns? I do this, then you do this, then you do this, and I do this. That one, it's simpler than the repeated games. You're just going to solve the tree backwards, guys. Think logically, think strategically. Everyone's thinking ahead to the end. What's player B going to do? Based on that, what should player A do? Player A will make a choice which pushes B to the best outcome for A. You'll figure it out. It's in the videos too. I've rambled enough. I think game theory is fascinating. It's easier than what we did in chapter 11 for the most part. And it's very flexible. I have personally seen game theory used to model nuclear negotiations, like nuclear warfare type negotiations, like Cold War stuff. I've seen it used to model the Federal Reserve deciding how much it can push a threat onto Wall Street banks. I've seen it used to model uh, environmental protection agency imposing restrictions on firms and how the firms respond to each other. You know, like who goes green first and whatnot. Like all kinds of stuff. This game theory idea, I mean, it feels kind of like a toy, but the idea of thinking strategically and thinking in terms of, if you do this, what's my best outcome and what should I do and where are we all going to end up if we do this? That's relevant to basically anything you'll end up doing later in life. Thinking strategically is the general idea, this is the general hope that we take from this chapter. It's not super thorough, but it's a start. If you want to learn more, let me know. I can tell you some cool resources. I hope that's helpful. If not, too bad. Thanks for watching anyway, guys. Good luck. I'll see you later.